Hey guys, it's Tanya from Trio here, and I am, as you all know, an academic mentor and a tutor. And for today's video, we're going to be going over Intro Chem Chapter 4, which is Atoms and Elements. In this chapter, we're primarily going to be working with the periodic table, so you need to grab one and have it handy. We're going to be discussing quite a bit of information from this periodic table, so I'd like for you to have one handy so you can follow along. Alright, so some of the things that we need to talk about in this video are elements. So elements are listed on your periodic table, and they are defined by their number of protons. And the way that the periodic table is divided, and we'll get a closer look at the periodic table here momentarily, but we have it divided between metals, metal alloys, and then nonmetals, okay? And so you need to be able to identify these on your periodic table. Now the one that I use is color-coded. If you don't have access to a color printer, then you can always just print it out in black and white and then use a colored highlighter to highlight the different metals, metal alloys and nonmetals. Okay, so those are some of the things that I wanted to point out. Some of the properties of metals are they have a metallic shine, so they have a luster, they conduct electricity, they conduct heat, they are malleable, they're ductile, they're solids, and their reactivity varies. So the reactivity varies based on what they are combined with, okay? And compounds with metals are mostly ionic compounds, okay? So what that means is that, and we'll go into this in more detail later, but ions, metals like to donate their electrons to the nonmetal element in a compound so that they become a cation, okay? So we'll talk about that more later, but they donate their electrons in order to become a cation, okay? So let's take a look at some of the properties of nonmetals, and we'll just talk about those real briefly. They're poor conductors of electricity. They don't maintain their heat very well. They're mostly found in compounds. So these nonmetals that are listed on the right side of your periodic table are mostly part of a molecular compound. There are some exceptions. Couple of exceptions are oxygen and nitrogen. They're not malleable or ductile, and their reactivity in a chemical equation varies based on what it's combined with. And the compounds with nonmetals are molecular, okay? So just a little bit of information that you need to know regarding metals and nonmetals. Okay guys, so I have taken one element from the periodic table and have broken it down and to tell you what each part of this means, right? So the number 4 is the atomic number. It's also the number of protons in this element, beryllium, okay? It's often represented with the letter Z, right? So then your Be, this is your chemical symbol. Then your 9.01, this is the weight of this element. So it's the atomic mass. And then underneath is the name of the element. So as you're looking at your periodic table and you're looking at the chemical symbols and the names, some of them don't always go together. There are some elements that were renamed, like iron. It used to be called ferrous or ferric. It is now, and it was represented by the symbol Fe, And now on our periodic table, it's still represented with the symbol Fe, but we acknowledge it as iron. So each element is usually named for the scientist that discovered it. Whoever identified that element had the ability to name it. So you'll see some pretty neat ones, germanium, just different elements on your periodic table with interesting names. I'm not going to really get into that. Your professor will talk about that a little bit in lecture. But I just wanted to show you each part of each element on the periodic table. You're going to get very familiar with this periodic table because we'll be using it from here on out for the rest of the semester. And your professors are also going to ask you to memorize about 50 of these elements, and you'll be tested on it. So when you start your memorization work, I recommend creating flashcards for each element and including all of this information. Because when you're tested on these elements, you could be tested on any part of it. You could be given silver and asked, okay, so what is the atomic number for silver? What is the, what is the chemical symbol for silver? Because it's not what you would think it is. Silver is actually Ag, right? But we know it as silver. So become familiar with these elements. Check your professor's lecture and their lecture notes. They'll tell you what elements that they want you to memorize, and it's something that you need to get started on now because 50 elements is a lot, especially when you have other things going on. So make yourself some flashcards and then look at them in your downtime while you're watching TV, while you're waiting on your laundry to dry or whatever. Just take the time and make those flashcards, guys. I can't tell you how helpful they are. They really helped me, and I know a lot of my other students found the flashcards to be very beneficial. Okay guys, so what we're going to do is I have drawn this chart on the board, and you're going to see something just like it in your professor's lecture notes probably. And I'm just doing this so that we can familiarize ourselves with the periodic table and be able to identify those important parts: the number of protons, the number of neutrons, the number of electrons, the mass number, and the name of the element. So the one that your professor has in the lecture includes more elements than this one does, but I just thought we'd do the first couple together just so you would get the understanding, get the hang of it. So using our periodic table of elements, we're going to take a look at chromium 52, okay? And we're going to determine the number of protons, the number of neutrons, the number of electrons, the mass number for this particular element, okay? So when we look at chromium on our periodic table, chromium is actually going to be, well, where is it? Here it is. It's element number 24, okay? So element number 24 is chromium, and the mass of chromium is 52, hence chromium 52. So we need to be able to determine from that information on chromium how many protons, how many neutrons, and how many electrons. Okay, so chromium is one of the transition metals, right? And so that means that it can take on more than one charge. It's in the center here, the transition metals. So when we look at chromium, we can see that chromium has 24 protons, 28 neutrons, and your protons and your electrons are generally the same. And then our mass number is 51 0.99. Okay, so basically what I did was I took, we're just going to round this up to 52. So I took the mass number, subtracted the chemical number, right, the atomic number, and that gave me the number of neutrons. So my protons and my electrons are the same for this exercise. So that's where I came out with 28. So 52 minus 24 is 28, or 52 minus 28 is 24. Okay, so now we're going to look at our next element, and this one is not identified, so we need to figure out what element this is. Okay, so based on the information that we're given, it has 25 protons and 30 neutrons. So that tells me that it has a mass of 55. Okay, so I can look at my periodic table and see what on the periodic table has a mass of 55. Well, that would be manganese. So that's going to be manganese. And so we need to write it down here. Okay, so now I can take my information here and say, oh, well, I know that my protons and my electrons are the same. So for manganese, we have 25 electrons. And so this column is complete. Okay? All right, so then our next one, we're only given the number of neutrons and the number of electrons. So once again, going to my periodic table, I look at my elements here and going to the atomic mass, looking the atomic mass. Well, I can't really use my atomic mass because all I have is my number of neutrons and my number of electrons. But if I add the two of those together, I get 112. Right? So that'll help me identify my element. I'm one step closer to identifying my element. So when I go to my periodic table, I'm going to find the element with a mass of 112, or as close to 112 as we can get, and that's going to be cadmium. Right? And so I know that my protons and neutrons, or protons and electrons, are the same. So just completing the table here. This is what we get. So the purpose of this exercise was to it's kind of like a precursor to isotopes, because an isotope is an element that has the same weight but different numbers of protons, right? So they have, or excuse me, the same number of protons, different number of neutrons. So they can be the same element, but there's just one or two things that are different, right? And when we work equations with isotopes, we are given a percent abundance. So the percentage of that particular element. So it could be an oxygen isotope, and it could be oxygen 18 and oxygen 17. And so you've got 94% of oxygen 18, 6% of oxygen 18, right? So that's just an isotope, and we'll get more into that later, but I wanted to show you this just for the purpose of being able to identify this information from your periodic table, because it is important, especially as we move forward and start working with charges and learning our elements that our professor has asked us to learn. Okay guys, we're going to work through this problem of calculating atomic mass. So we take our given information, which is the fraction of gallium-69. It has a mass of 68.9256. And then the fraction of gallium-71 with a mass of 70.9247. We're given the natural abundance of the gallium-69 is 60.11%. So we need to determine the natural abundance of the gallium-71, and then we need to convert the percentage into decimal form, right? So with percent abundance, it's always going to equal 100%. So to determine the amount of natural abundance of gallium-71 based on the information that we're given, we're going to take 100 and subtract 60.11, right? And so that's going to give us 39.89, excuse me, percent. Okay, so this is our percent natural abundance of the gallium-71. So then in order to convert this into decimal form, we're just going to divide by 100, okay? And so that's going to give us a decimal of 0.3989, right? Same thing with our 60.11. We're going to divide that by 100, and we're going to get 0.6011. Whereas if we add these two together, we get 1, right? So we'll have to come back. We need this information in order to determine the mass of these two isotopes. Okay, so calculating the atomic mass of two isotopes is pretty simple. So we have our atomic mass, is equal to our percentage of natural abundance, which is 0.6011. We're going to multiply that by our mass, just 68.9256, and then we're going to add it. So this is for our gallium-69. So for our gallium-71, we're going to take our percent natural abundance, which is the 0.3989, and we're going to multiply it by the mass of 70.9247. So we're going to do our math, and then we're going to add these two together, and that's going to give us an atomic mass of 69.7231. We're going to round that. Should be 69.72 AMUs, right? So now that we know how to calculate this, we'll be able to work through any type of isotope equation. There are some posted, depending on which professor you have. If you have Professor LaPaula, she has several of these in the homework that she's posted for Chapter 4. So that's really good practice for you. As I stated, the concepts that we're learning in these early chapters, we're going to be using for the remainder of this semester, right? And so you've got to grasp a good understanding of these concepts and skills in order to be successful. And everybody wants to be successful because you want to go on to your nursing program or your dental hygiene program or your medical lab tech program. Whatever program it is that is in your future, Intro Chem is at the basis of it. And with the programs here at Rose, they're points based, so the better you perform in your classes, the more points you get. So that just ensures your chances of getting into that program. So that's why these skills and concepts are important. The homework is important. Tutoring is important. So guys, once again, if you need help with this stuff, reach out to me. I'm in the TRIO office 3 days a week, 4 days a week, available by email. You can message me on Canvas. We're going to have TRIO is going to be available on your Canvas. So, I mean, there's several different ways to reach out to TRIO and get the assistance that you need in order to be successful. So just keep that in mind. We'll go ahead and we'll work on a couple of other isotope problems together. Maybe one. And then that'll give you a good foundation for the homework that your professor has prepared for you. Okay guys, so I put this problem on the board, and we are going to find the average atomic mass of neon. This came straight off of my homework that I had when I was in intro chem, so I just thought it was a good practice. So let's take a look and see what we've got here. We've got neon 20 with an atomic mass of 19.9924 and an abundance of 90.51. Then we have neon 21 with an atomic mass of 20.9940 with an atomic, a percent abundance of 0.27. And a neon 22 with an atomic mass of 21.9914 with an abundance of 9.22. And remember, when you add these abundances up, they should equal 100. All right, so to calculate the atomic or the average AMU of neon, we're going to do this within 4 sig figs. Okay, so we're going to take our atomic mass, we're going to multiply it by our percent abundance. We first need to divide this by 100 and put it into decimal form. So that's going to make this 0.9051. We're going to add this to our neon 21, which is atomic mass of 20.9940 multiplied by our percent abundance, which is going to be 0027, and then we're going to add that to our neon 22, which is 21.9914 times 0.0922. That's going to give us 18.095. 12124 plus 0.056 683 2.027 60708. A lot of numbers after the decimal. That's why we wanted to do it to 4 sig figs. But we don't round our intermediate products, if you remember that as one of the rules of significant figures. So when we add these together, we're going to get 201,794,1212. And of course, if we were to round that up to 4 significant figures, that gives 20.18 AMUs. Okay? So there's that. Alright, so guys, that'll be it for this video. This is a little bit shorter than I had thought it was going to be, which is a good thing, because that gives you time to work on other things, such as homework or getting prepared for your first exam that's next week. Once again, I am here and available for tutoring in the TRIO office. I am in class on Tuesdays and Thursdays, so I'm available Monday, Wednesday, and Friday for tutoring. If you have a special situation and can't make it on Monday, Wednesday, or Friday, let me know and we'll see if we can't work something out. I'm flexible, but you know, I have some limitations because of my own class schedule. So just let me know what it is that you're needing help with, and I'll do everything that I possibly can, even if it's a Zoom session, to try and to get you some tutoring assistance as we move forward through the rest of the semester. So as always, guys, thank you so much for watching. Stay safe, stay healthy. See you next time.